converting parametric form to rectangular or Cartesian forms. So let's consider once again this equation we were working with, x equals 3t squared and y equals 2t. I want to write these things as a rectangular equation. Well, if x equals 3t squared, that implies then that t squared is equal to x over 3, which means that t is equal to plus and minus the square root of x over 3. Well, if that's what t is, then y, which equals 2 times t, must be equal to plus and minus 2 times the square root of x over 3. The plus and minus makes sense because remember our graph started here and it went like this. Well, the only way I can get this as a function in Cartesian coordinates would be to start off perhaps here, that's the positive of it, and then repeat it with a negative, which is a mirror image, to bring me down to here. So it makes sense that I'm going to have to actually do two functions to represent that one that we were dealing with. So let's go ahead and actually plot that. But actually, before we do that, the original had a domain of -2 less than or equal to t, which is less than or equal to 2. The original domain was restricted, so we need to think about what the domain is here. Because if I just graph this, this is going to look basically like this and go on to infinity. And then the negative of it, the mirror image of it, about the x-axis, is going to look like this and go off to infinity. So what I need to do is figure out how to cut it off here and here to match the original function. Well, if the original domain for t was -2 to 2, I have a plus and minus here, so I'm going to work with just a positive for a moment. That would then imply that 0 must be less than or equal to t, which is less than or equal to 2. So if I solve that, what I'm going to end up with is 0 is less than or equal to, we said t is the square root of x over 3, which is less than or equal to 2. That implies that 0 is less than or equal to x over 3, which is less than or equal to 4, which implies that 0 is less than or equal to x, which is less than or equal to 12. So if x goes from 0 to 12, then I will go ahead and get 0 to 12 like this. And then, of course, the negative of it would just come around back down here. So now let's go ahead and take a look at the graph and see what we get. Well, I'm in this parametric form, so I need to come back to functions. And once I'm back in function, I already put it in, both the plus and the minus. And let's see, if I go to my window, I'm going, x I'm showing from -1 to 12, so I can see a little bit to the left. And if I graph it, see there's a positive, there's a negative of it. And here's 12, so I stop there at 12.